एवरीवन, आज हम लोग शुरू करने वाले एयरक्राफ्ट वेल्डिंग। Welding can be traced back to the Bronze Age, but it was not until the 19th century that welding as we know it today was invented. Some of the first successful commercial manufactured aircraft was constructed from welded steel tube frames. As the technology and manufacturing process evolved in the aircraft and aerospace industry, lighter metals such as aluminum, magnesium, and titanium were used in their construction. The processes and methods of welding these metals were developed. This chapter provides some of the basic information needed to understand and initiate the various welding methods and processes. Traditionally, welding is defined as the process that join metals by melting or hammering the process workpiece until they united together. With the right equipment and instruction, almost anyone with some basic mechanical skill, dexterity, and practice can learn to weld. First types of welding. Gas welding. Gas welding is accomplished by heating the ends or edge of metal parts to a molten state with a high temperature flame. The oxyacetylene flame with a temperature of approximately 6300 Fahrenheit is produced with a torque burning acetylene and mixes it with pure oxygen. Hydrogen may be used in place of acetylene for aluminum welding, but may be used in place of acetylene for aluminum welding, but the heat output is reduced to about 4800 Fahrenheit. Gas welding was the method most commonly used in production on aircraft material under 3 by 16 inch in thickness until the mid 1950s, when it was replaced by electric welding for economics, not engineering reasons. Gas welding continues to be a very popular and proven method for repair operations. Electric arc welding. Electric arc welding is used extensively by the aircraft industry in both the manufacture and repair of aircraft. It can be used satisfactorily to join all weldable metals, provided that the proper processes and materials are used. The four types of electric arc welding are addressed in the following paragraph. Shielded metal arc welding. Shielded metal arc welding is the most common type of welding, is usually referred to as stick welding. The equipment consists of a metal wire rod coated with a welding flux that is clamped in electrode holder that is connected by a heavy electrical cable to a low voltage and high current in either alternating current or direct current, depending on the type of welding being done. An arc is stuck between the rod and the work and produces heat in excess of 10,000 degree Fahrenheit, which melt both the material and the rod. The welding circuit consists of welding machines, tool head, an electrode holder, and electrode, and the work to be welded. Gas metal arc welding. Gas metal arc welding is formerly called metal inert gas welding. It is an improvement over stick welding because an uncoated wire electrode is fed into and through the torque, and inert gases such as argon, helium, or carbon dioxide flow out around the wire to protect the puddle from oxygen. Welding eyewear. Welding a protective eyewear for use with oxy-fuel welding output is available in several styles and must be worn to protect the welder eye from the bright flame and flying spark. This eyewear is not for use with arc welding equipment. Torque lighter. Torque lighter are called friction lighter or flint striker. The lighter consists of a file-shaped piece of steel, usually resist in a cup-like device, and replaceable flint, which when drawn across the steel produces a shower of spark to light the fuel. Filler rod. The use of the proper type of filler rod is very important for oxyacetylene welding. This material adds not only reinforcement to the weld area but also desired properties to the finished weld. By selecting the proper rod, tensile strength or ductility can be secured in a weld. Similarly, the proper rod can help retain the desired amount of corrosion resistance. In some cases, a suitable rod with a lower melting point helps to avoid cracks caused by expansion and contraction. Different types of flame. The three types of flame commonly used for welding are neutral, carbon, and oxidants. Each serve a specific purpose. Neutral flame. The neutral flame burn at approximately 85850 Fahrenheit at the tip of the inner luminous cone and is produced by a balanced mixture of acetylene and oxygen supplied by the torch. Carburizing flame. The carburizing flame burn at approximately 5700 degree Fahrenheit at the tip of the inner core. It is also referred to as a reducing flame because it tends to reduce the amount of oxygen in the iron oxide. The flame burns with a coarse rushing sounds and has a bluish white inner cone, a white center cone, and a light blue outer cone. Oxidizing flame. The oxidizing flame burns at approximately 6300 degree Fahrenheit and produced by burning an excess of oxygen. It takes about 2 parts of oxygen to 1 part acetylene to produce this flame. It can be identified by the shorter outer flame and the small white inner core. To obtain this flame, start with a neutral flame and then open the oxygen valve until the inner cone is about one tenth of its original length. The oxidizing flame makes a hissing sound and the inner cone is somewhat pointed and purplish in color at the tip. Soft and harsh flame, which with each size of tip a neutral carburizing and oxidizing flame can be obtained. It is also possible to obtain a soft or harsh flame by decreasing or increasing the work pressure of both gases. Observing the maximum work pressure of the 15 psi for acetylene gas.